Hello everyone and welcome to the YouTube channel Yacht Design Academy. My name is Gabriele, I'm a yacht designer and professor of yacht design, and today we are going to talk about are the longer boats faster and why? To answer to this question we have to introduce two concepts. The first one is the relative displacement, and the second one is the relative sail area. Why relative? We know that the displacement is the weight of the boat. But to compare different boats with different dimensions, we have to introduce the relative displacement. The displacement compared to the length of the boat, to the length water line to be precise. So the relative displacement is the displacement of the boat divided 0.01 time length water line of the boat at the power of 3. In this case the displacement is in English ton, which 1 English ton is 1016 kilograms, and the length water line is in feet. Why this formula? Because the displacement is linked to the volume, and the volume is a length power 3. So here the length water line has to be power 3. And what's the relative sail area? Is the sail area divided the displacement power 3 divided 3, 2 divided 3. Again, the sailing area is a unit power 2 because it's an area. The displacement is a volume, so is power 3. And we have to harmonize the two different dimensions in this way. In this case, sail area is in square meter and displacement is in ton. Let's consider this boat. Hansa 315 is a sailing boat, of course, and the hull length is 9.1 meter. Length water line is 8.7 meter, hull beam is 3.35 meter. So the first consideration is the length beam ratio is 2.72, which is 9.1 divided 3.35. The length beam ratio is basically a number can give us the ratio between the length and the beam. We will see that this factor will change with considering different type of boat. Displacement is 5 ton and 300 kilos. Total sail area is 47 square meters. So the relative displacement is 224 and the relative sail area is 15.4. Again, the relative displacement is this one. Basically is the displacement compared to the length water line, and the sail area is this one. The sail area compared to the displacement. Let's go on. For the answer 458, we have a hull length 13.5, length water line 12.2, hull beam 4.38, length beam ratio 3.09, a little bit better. And the displacement is 12 ton and 100 kilo. Total sail area 103 square meters. So the relative displacement is 185.7. Before was 224. So we are going better, we are lighter, relatively speaking. Sail area, relative sail area is 19.5. Before was 15.4. So we have, relatively speaking, a lighter boat with more power. Lighter, 185 against 224, and with more sail area, considering the displacement. 19 against 15. Let's go to consider the answer 675. Hull length 20 meters, 0.5, length waterline 19.2, hull beam 5.9, length beam ratio 3.47. Better and better. Displacement 37 ton and 800 kilos. Total sail area 244 square meter. Relative displacement 148. Relative sail area 21.7. So again, we are lighter and with more sail area, relatively speaking. Southern Wind 96, a custom boat, bigger boat. Hull length 29, length waterline 26.8, hull beam 6.95, length beam ratio is 4.21. Displacement is 60 ton. Total sail area 495 square meter. So relative displacement is 86.9, let's say. Relative sail area is 32.3, let's say. So also here again we are going better because we have a lighter boat, 86 against 148, with more power, more sail area, 32 against 21. So here the recap. Basically, going from smaller boat to bigger boat, we have a better length beam ratio. We have a relative displacement going from 224 to 86, so it's the boat is lighter, relatively speaking, from here to here. The sail area, relative sail area, basically the sail area compared to the displacement, is going from 15 to 32. Basically, the bigger boat has the double of the power of the sail area with almost one third of the displacement. This is explained very well why bigger boats are faster, because all the numbers are pushing a bigger boat to go faster. Max speed. This is a very popular formula saying the max speed of the boat is 1.34 times square root of the length waterline. I don't like very much this formula because it's considering only the length waterline, but if we think to very different type of boat, a very old boat, a cruise boat and a race boat, we can easily understand the length waterline can be the same, but the speed can be completely different. Because to consider only one dimension, the length waterline, is not enough. We can have the same length waterline with different displacement, different shape of the hull, different keel, different sail area. So it's not, I don't like very much this formula, but again, it's very popular, and so I have mentioned this formula. And we are going from 7 notes to 12.5 notes. So again, we can understand that the bigger boat, longer boat are faster. Okay, thank you very much, and please subscribe to my channel, and see you next time.